All right, so we need to talk about some ways to quantitatively, or with numbers, discuss concentration of solutions. All right, so the next couple of lessons are going to be related to several different ways to do that. This lesson is going to focus on molarity and mole fraction. So these are both numbers or ways to calculate and display a concentration quantitatively. So molarity is the concentration of a solution expressed in moles per liter. All right, so to solve for molarity, you take, helps if I have my pen going, your moles of solute, and you divide by your volume, and this is important, in liters. All right, so molarity has a unit of a capital M, and then whatever it is that you were dissolving, whatever your solute was. So if you're describing the concentration of, say, hydrochloric acid in a solution, you would say that it's, 2.0 capital M molar hydrochloric acid. Or you might do, 0.75 molar sodium chloride, something like that. All right, that way we can tell this M apart from, say, like meters or something like that. If we include the chemical name, that lets us know that, oh yeah, we're talking about concentration. So we need to review calculating molar mass. This is going to be important for molarity, for mole fractions, also for molality in the next lesson. So you need a periodic table. All right, Google one. There's one in the back of your lab manual. I'm going to put a link in the description of this play post-it assignment. So just have a periodic table handy. And then I'm zooming in on our mole island diagram, because if you remember, to go from mass, which is usually what we're going to measure our solutes in, to moles, all right, we're going this way. You're going to divide by your molar mass. All right, so that's why we need to review how to determine molar masses and how to calculate moles from them. So to do these calculations, you're going to take the mass of your solute, so how much you're actually adding to your solution, and you're going to divide it by the molar mass of said solute. And that's how you'll get your moles of actually, that would make more sense over here. That's going to be how you get your moles of your solute. All right. Now, to remember how to do molar mass, that's where your periodic table comes in handy. All right. So periodic table is here. So magnesium and chlorine, we can look up their masses on the periodic table. So to figure out the molar mass of magnesium chloride, you need to combine the mass of 1 magnesium and 2 chlorines, because that's what's in our formula, 1 magnesium, 2 chlorines. So magnesium has a mass of 24.3. You're fine just rounding that to the nearest whole number. So I'm going to do 24. Chlorine has a mass of 35.45, so I'm going to add 2 35s, which will give me 94 grams per mole. All right, so now to calculate my moles, I'm going to take my mass of my solute. All right, so that's going to be the 234 grams, and I'm going to divide that by my 94 grams per mole, which is going to give me 2.49 moles of magnesium chloride. All right, I say you pause the video, try the 21 grams of carbon dioxide on your own, see what you get. But again, we need 1 carbon and 2 oxygens. So it's going to be 12 plus 16 plus 16, which equals 44 grams per mole. Then I'm going to take 21 divide it by that 44, which will give me 0.48 moles of carbon dioxide. All right, I'll do one more. And you can always try a few more of these examples if you like. But NaCl, you're going to combine Na plus Cl. Na has a mass of 22.99, so I'm just going to call that 23 plus 35 is 58 grams per mole. And then I'll take the 145 divided by 58. And that's going to be 2.5 moles. Okay? If you need more review with this, talk to me. So, putting this into a calculation. Most molarity problems you're going to see are going to have something like this. What is the molarity of 12 grams of barium chloride, BaCl2, in solution with a volume of 560 milliliters of water? All right, if you remember, molarity is the moles of your solute divided by your volume in liters of solvent. All right, so first thing we got to do is figure out our moles of solute. So we have 12 grams of barium chloride, but we need to convert that to moles, which means we're going to have to figure out the molar. So moles BaCl2 equals 12 grams over molar mass. All right, so our molar mass is going to be a Ba plus a Cl plus a Cl, which barium is down there. It's going to be 137 plus 35 plus 35, which will be 207. Yeah. All right. So our moles of BaCl2 is going to be 12 divided by 207, which is going to be a somewhat tiny number. .058 moles. All right, so there's our moles. We're going to plug that in up top. And then the other thing is we need our volume, but we need our volume in milliliters. All right. So we have 560 milliliters of water. To get that into liters, I'm going to divide it by 1,000 milliliters per 1 liter. My liters will cancel out, and that's going to be 0.560 liters. So to plug this all in, 0.058 on top, and 0.560 liters on the bottom, which ends up giving me 0.10 molar BaCl2. All right. Very often you are going to see your volumes given to you in milliliters, so just remember, to go from milliliters to liter, you just divide by 1,000. So mole fraction is another way of describing concentration of a unit. It's the fraction of your moles of solute divided by your total moles. All right? You're just creating a fraction. There's no unit on mole fraction because you're just dividing moles by moles, so the units cancel. So for example, suppose you have a solution made from 200 grams of ethanol and 350 grams of water. What is the mole fraction? The tricky thing here is these values are given to us as masses. We need to convert both of those to moles. All right, so our 200 grams of C2H5OH, we need to convert that to moles. All right, which means we need our molar mass of ethanol, which is going to be 2 C's plus 5 H's plus an O plus one more H. All right, so we've got 12 plus 12 plus 1 plus 1 plus 1 plus 1 plus 1 plus 16 plus 1. All right, so getting those right off the periodic table. Carbon was like 12.01, so I rounded that to 12. Hydrogen is 1.007, so I round that to 1. Oxygen is 15.99, so I round that to 16. All right, so we've got 24, 30, 46 grams per mole. All right, so I'm going to take that 200 grams and divide it by 46, which gives me 4.35 moles of C2H5OH. All right, let's do that again for water. All right, so I need to take that 350 grams of H2O, convert that to moles. So that's going to be H plus O, or 1 plus 1 plus 16, which is 18 grams per mole. So I'm going to have 350 divided by 18, which is equal to 19.4 moles of H2O. All right, and now my mole fraction is just my moles of solute divided by my moles of solvent. All right, so that's going to be my mole fraction is equal to 4.35 divided by 19.4, and let me just plug that in the calculator. Which is equal to 0.22. No units because I'm dividing moles by moles. Units are going to cancel out.